Hi everyone, I am Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. In this lecture series video, we are going to discuss about the introduction of queuing system. So what is queue? A queue is a waiting line. It can refer to a line of people or vehicle waiting for something, or it can be more abstract concept in computing referring to an order list of items waiting to be processed. That means peoples arrive in a queue and getting service. After that they may leave the queue. This entering is called queuing system. For example, people waiting in line at a ticket counter, print jobs waiting to be processed by a printer, message waiting to be sent over a network. So the key components of waiting. What are the key components? Before that, what is customer? So anything that arrives at a facility and requires service is called customer. That means people, machines, data packets, this everything as customer. If customer is there, who is server? So what is server? The resources that provides service, that is called servers. That means staff, equipment, a process, these all are called server. So queue. So what is queue? A waiting line or buffer where customers wait for service. In this figure, we clearly note that the customers arise and they form the queue, then getting service. After that, he will get exit. So this everything as service system. So basic characteristics of queuing system. So what are the basic characters? The basic characters of a queuing system are as follows: input or arrival pattern, service mechanism or service pattern, queue discipline, customer's behavior. These all are basic elements of queuing system. So in this figure, we easily understand that. So here the customer arrive the system and he get the service, then he may leave the queue. So it is queuing characters. So first we discuss what is input or arrival pattern. The input describes the way in which the customers arrive and join the system. Generally, the customers arrive in more or less random fashions, which is not worth making the predictions. So how many customers will join the queue and whether it is finite or infinite, we don't know. So definitely it may be either finite or infinite. So the number of people join the system, so we don't know how many people there. Therefore it is calculated by the Poisson functions lambda. So what is inter-arrival rate? The inter-arrival rate is called lambda. That means the arrival of one arrival to another arrival, the time gap between one arrival to another arrival is called inter-arrival rate. So it is denoted by the letter lambda. Okay. Next, what is service pattern or service mechanism? The service mechanism is specified, or service pattern is specified when it is known how many customers can serve at a time. So what is the statistical contributions of service time and is when the service is available? Service time may be customer or a random variable. Distributions of service time, which is important in practice, the negative exponential distributions. The mean service rate is denoted by mu. So service rate is available when it is a capacity, it is a depend on capacity of the system. So here the service is calculated from this. The customer joined the queue or the customers are waiting in the line, then he enter to the service and get the service by a single service or a double service, or it is in multiple service. So next we are going to discuss about the queue discipline. So what are the queue discipline? The queue discipline refers to the order or manner in which customers join queues. It describes the method used to determine the order in which customers are served. So there are several disciplines in the queue. The first one is first in first out, or last in first out, or SIRO, service in random order. So these three are queue discipline. So what is first in first out? The customer first in first out or first come first serve, FCFS. The customer are served in order in which they join in the queue. For example, the prepaid taxi queue at the airport, where the taxi is engaged on a first come first serve basis. The people arrive and the taxi is available, then the people use the taxi. It is in first out. And last in first out, that is LIFO, or last come first serve. In this system, the elements arrived last will have to the chance of getting service first. In general, this does not happen in a system where human beings are involved. However, this is quite common in inventory system. In a big godown, the unit which come last are taken out first. That is an example of last in first out. Service in random order. Next we have discussed about SIRO, that is service in random order. In this case, items are called the service in a system or in a random order irrespective of their arrival order in the system. For example, in government offices, applications for various favors are picked up randomly for processing services. And next we have the important things is a customer behavior in the system. So what are the behaviors by the customers? The first one is called bogging. The bogging, a customer may leave the queue if there is no waiting space. The next is reneging. A customer may leave the queue after waiting for some time due to impatience. So in this figure here, we have the bogging. So in this first line, the blue arrow line is bogging. That means a customer joined the system and he expect the system is not moving, then he is leave. There is no waiting space. He decide that there is no waiting space here, then he leave that. So this type of character is bogging. And reneging, the customers join the queue and the customer moving inside the queue. After certain stage, he is impatient, he leave the queue. So this type of characters are called reneging. And the next one is called priorities. In certain applications, some customers are served before others regardless of their order of arrival. That means the customers are waiting for his turn is there, then he is getting the service. That type of character is called priorities. The next is joking. Joking is the customers may jump from one waiting line to another waiting line. So these four characters are customers' behavior in the system. Finally, we calculate what is the length of the system, what is the average queue length, and what is the expected time. So we calculate everything things. Here first we use the model. The model is called MM1 infinity, first come first serve. The first M is number of service, second is number of customers, second M is number of customers, and one is number of service station, and infinity is number of customers, and queue discipline first come first serve. So to find the average or expected number of units in the system is LQ, LS, that is length of the system, is calculated by rho divided by 1 minus rho, where rho is lambda by mu. So rho is always less than 1. So rho is called utilization factor, or the system is always busy. On that case, we apply this rho. Rho is lambda by mu. Lambda means inter arrival rate, and mu is service pattern, service number of service. And the second is the find the average length of the queue, that is LQ is rho square by 1 minus rho. And the third one is expected waiting time in the system. That means 1 by, that is a W expected waiting time in the system. So waiting here, therefore it is a WS system. That means 1 by mu minus lambda. So next one is what in waiting time in the queue, that is WQ is rho by mu minus lambda. Already we know rho means lambda by mu. Therefore the waiting time in the queue is lambda by mu into mu minus 1. So that's all this introductions part of a queuing system. In our next video we are dealing we take some problem, and from the problem we analyze all these 4 categories or some 5 categories of concept of expector. What is the length of the system, what is the length of the queue, and the waiting time in the system, waiting time in the queue, and what is the probability for end customer in the system, and what is a zero customer in the system. We collect everything, we calculate everything in the next video. So thank you.